Hello, Advanced Math. This is Mrs. Harbin, and this is Lesson 2.2 on substitution, solving systems of equations through substitution. Our biblical integration is this. God does not promise that everything will be equal, but He does allow us to grasp the concept of more and less so that we can compare. And we're going to look at more and less when we're talking about inequalities and graph these inequalities and see where they intersect on a Cartesian plane. So let's take a look at this lesson opener. Solve 2x plus 3y equals negative 10 for y by substituting the given value for x. This is just an evaluation problem, a plug and chug. So let's substitute x equals 4. Let's substitute that 4 in for x. And when we solve for y using algebra, we get y equals negative 6. If you don't know how we did that, let's go back and look at those steps here. We would get 2 times 4 equals 8 plus 3y equals negative 10. We would need to subtract 8 from both sides and get 3y equals negative 18. Divide both sides by 3 and we get that y equals negative 6. If you need help with that, make sure you see me for a review. What about when we solve this equation using the value of x equals negative 2? Try that one on your own. Plug and chug, and then resume this video and see if you get the correct answer. Hopefully you got y equals negative 2. What about when x equals y? What would you do? Well, just like in all the other equations, we're going to plug in the value. So instead of x, we're going to have y. And we get 2y plus 3y equals negative 10. Add our like terms, we get 5y equals negative 10. Divide both sides by 5, and you get y equals negative 2. So we can substitute numbers in and evaluate like we have been doing, or we can substitute other variables in like we did with that problem right there. What about when x equals 2y? Well, substituting that in, we would change our x to 2y and use the distributive property, combine like terms, and we would find out that y equals negative 10 over 7. Solve 2x plus 3y equals negative 10 for y by substituting the given value for x. X equals y plus 5. Just like before, when we substitute, we're going to use parentheses here. And instead of x, we're going to put y plus 5. And then we're going to simplify. To get rid of those parentheses, we would have to distribute. So we would take 2 times y plus 2 times 5. That gives us 2y plus 10. Then we start combining our like terms and isolating the variables so that we find out that y equals negative 4. So we can substitute known values for x, or we can substitute other variables. Whatever the problem tells us to do, whatever we need to do to be able to solve for a variable, we can use substitution to help us solve for that variable. Our lesson objective is this. You, the student, will solve equations with multiple variables using substitution. So solving a system by graphing, which is what we did in the previous lesson, that works well only if the coordinates of the solution are small integers. If we had linear equations whose solutions are 1,347, that doesn't work so well because that would be a really big graph, and that's not really feasible for us to be able to do on the graph paper that we have. Plus, it would take us a lengthy amount of time. So graphing works well when the solution set is small integers. Another method should be used if the solutions contain large integers or fractions. Fractions are also difficult to graph in the Cartesian plane, so it's not the best way to solve those systems if you're going to have fractions. And the substitution method then is a second method that we can use to solve linear equations. This is used to find a single variable equation by replacing one of the variables with an equivalent expression. So substitution is a great method when you're not dealing with small integers or when you're dealing with fractions. Once this equation is solved, the result is substituted into one of the equations to find the value of the other variable. I think this will make more sense once we see it in action. So let's take a look at an example. I have two linear equations, x plus y equals 5, and y equals negative 3x plus 7. As you can see, we already know the value of y. The value of y is negative 3x plus 7. We can substitute that into our first equation where we don't know the value of y. And so we have x plus, and instead of y, we can substitute this y equals negative 3x plus 7 into this other equation for y. So we're subbing one known value into another equation. What that does is eliminate the y completely, and now I have only two variables, and they're both x's. So I know that I'll be able to combine those because there will be some like terms. I get negative 2x plus 7 equals 5 once I simplify combining like terms. Using our inverse operations and rules of algebra, let's solve for x and find out that x equals 1. Well, now I know the value of x, so I can go back into my original equation and substitute that back in to find a numerical value for y. So substituting that 1 back in, again use parentheses whenever you substitute, we find out that the numerical value of y is 4. So our solution set is 1, 4. Our coordinates are 1, 4. Sometimes you have to do some work before you can make the substitution. In the previous example, it already told us what y was equal to. Sometimes we're going to have to solve for y first. So in this set, we have x plus y equals negative 4 and x minus y equals 10. I'm going to solve the first equation for x and find out that x equals negative y minus 4. Now I know what x equals. I can plug that in over here into my second equation or substitute it into my second equation. Again, using parentheses, so I'm subbing in for x and I'm subbing negative y minus 4 all in parentheses plus my original operation minus y equals 10. Combining like terms gets me negative 2y minus 4 equals 10. And using inverse operations in algebra, I find that y equals negative 7. Now that I know that y equals negative 7, I can go back into that original equation that I had and substitute negative 7 in for y. Notice that my original negative sign stays here. I put parentheses around my y, and I've substituted negative 7 in for that y. It's really important because otherwise we wouldn't have those double negatives if we did not use those parentheses. We might drop one, and we don't want to drop that negative. We end up with x equals 3 once we combine our positive 7 and negative 4. So our solution is 3, negative 7. When solving a system by substitution, first solve either equation for either variable. Choose the easiest variable for you to solve for. So you can solve for x or y or whatever the variable is, and you can start with either one. You'll always end up at the correct answer. It doesn't matter if you start with x and the person next to you starts with y, or if you start with the first equation and the person next to you starts with the second equation. Start with the one that's easiest for you to solve for. After you have solved for a letter for a variable, then you're going to substitute the solution into the other equation to obtain an equation in one variable. So we want to substitute in so that our new equation has only one variable. All x's or all y's. Then we solve for that one variable. Use the numerical value of the known variable, plug it back into your original equation, and solve for the numerical value of that other variable. Write the solution as an ordered pair. Finally, check the solution by substituting it into each equation. Does the answer make sense? Is it logical? Is it a true statement? If so, then you have found the solution. You don't always have to solve for the same variable. Let's take a look at x minus 4y equals 0 and 3x plus 2y equals 8. If I solve for x, I get x equals 4y. I'm going to plug that 4y into the other equation, again using substitution and using parentheses. So instead of 3x, I get 3 times 4y plus 2y equals 8. Using the distribution property to get rid of parentheses and then combining like terms, I get 14y equals 8. Y then must equal 4/7. I'll plug that back into my original equation, and I get 4 times 4/7 instead of 4 times y, which leaves my x at 16/7. So my solution is 16/7 for my x value and 4/7 for my y value. Graphing that would have been difficult, so solving through substitution is a little bit easier because we're dealing with fractions. So today we solved equations with multiple variables using substitution. Solving for one variable, substituting it into the other equation to solve for the other variable, and ending up with both variables solved for a numerical value. Hopefully you remember that this is easier to do when, or better than graphing when it comes to large numbers or fractions. Graphing sometimes isn't always feasible or logical, so solving through substitution can work for any number of linear equations. If you have any questions, be sure to ask me next class.